So we will be taking you through 2014's free response question number 6. On the next slide, you will see part A. This part is very simple. All you have to do is find the point 0, 1 and follow the slope field through that point and follow the curvature of the graph. As we move through the slides, you can see the sketch of the solution curve take its shape as you see it pass through the point 0, 1. On the next slide here, we see part B, where we have to write an equation for the line tangent to the solution curve in part A at point 0, 1 and use the equation to approximate f of 0.2. This notation explains how you plug 0 in for x and 1 in for y to get 2 cosine 0 equals 2. On the next slide, you use point slope form to write an equation with the point 0, 1 and the slope of 2 that we got on the previous slide. And then this new equation, which is the tangent line, simplifies to y equals 2x plus 1. Then on the next slide, we plug in point 2 for x, and you get the approximation of f of 0.2, and it comes out to 1.4.
Now for part C. Part C asks us to find y equals f of x, which is the particular solution to the differential equation with the initial condition f of 0 equals 1. So what we need to do is take our differential equation dy over dx equals 3 minus y cosine x, and the first thing we need to do is separate our variables. What that means is we get the y's on one side of the equation and the x's on the other. And once we do that, we get dy over 3 minus y equals cosine x dx. And right after that, we need to integrate. So when we integrate, we must find out how to get the dy's and the dx's out of everything. So on the left side, whenever you have a fraction like that, what you want to do is take the natural log. And so we'll have negative ln of the absolute value, 3 minus y. And the reason there's that negative in front of the ln is because it's 3 minus y. So once you have that negative in the denominator, you need to put the negative out front. And on the right side, it's very simple. All you need to do is remember that the antiderivative of cosine x is sine x, and you always need to add the c because there's always a constant when you integrate. And we'll figure out what that is in a little bit. Now, we have to find what c is after we integrate, and we do that by plugging in the numbers that we are given in the initial question. So we were told that f of 0 equals 1, so we plug in 0 for x and 1 for y. And once we do that, we can solve for what c is, which will help us later. So when we plug those two numbers in and you simplify, it comes out to be that c equals negative ln 2. So what do we do with that? We plug in negative ln 2 into c, and now we're just solving for y. That is the last part of this question, and it might be tough, but we'll get there. So in order to get rid of all this, what we have to do is take e and raise it to the power of each side of the equation. So we have e to the negative ln of the absolute value, 3 minus y, and that gets rid of it for us, and we just have 3 minus y. And then on the right side, we do e to the sine of x and multiplied by e to the negative ln of 2. And there's a great rule that helps us out, and we can just combine the 2 and put it in front of the e, and we're left with 2e negative sine x. So once we have that, we just need to solve for y again. And we have 3 minus y equals 2e negative sine x, and all we need to do is move our variables around, and we come to y equals 3 minus 2e negative sine of x, and that is your answer.